The figure to the right shows the slope for the differential equation dy dx equals 1 minus xy. All right. Sketch the graph of a particular solution that contains 0, 2. Label this point as point A. So I hate these. I'm terrible at these, but let's try our best. 0, 2 lives right there. Okay, what you want to do is you want to use the slopes. Oh, by the way, we'll call you A. You want to use the slopes to kind of try to figure out the pattern as to what's going on. Okay, right here, I happen to be in between these two lines right here. So what I'm going to do is I'm going to try to trace along this slope and get that and get that. Again, we're not looking for perfection here because it looks like I had an anxiety attack while drawing that out. But that's the idea. You just kind of draw it out and sketch it to the best of your ability. Sketch the graph of a particular solution that contains -1, -2, which is going to be this guy right here. Okay, now this one doesn't necessarily fall on the thing. We're labeling it B, but we're still going to follow like the pattern. So this seems to kind of do a similar thing here, right? This seems to kind of then like go up here a little bit and maybe level out there. Okay, so drawing these things aren't fun. It's not a science. It's more of an art, and it's more of you, like I said, sketching things out and just doing the best that you can. And unfortunately, that's the best that I can. So please like and subscribe and leave a comment. The slope field for a certain differential equation is shown to the right. Which of the following could be a solution to the differential equation with the initial condition y of 0 equals 0? Well, y of 0 equals 0 is going to be the point 0, 0. So let's label it x and y. Let's go to 0, 0, and our slope is 0. So what we need to do is I need to basically look at all of these and see which of these is going to be matching up if I plug in 0, 0. So I can probably eliminate 1 or 2 or maybe even 3 of them if I plug in 0, 0. If I plug in 0, 0 here, I do get 0 over -4, so you will check out so far, so A is an option. If I plug in 0 for tangent, tangent of 0 is 0, and 2 plus x is 2, so you will check out. If I were to plug in 0 here, I would get e to the 2, so c is not an option because I will not get 0. And if I plug in 0 here, I get 0 over 2, which is 0, so you seem to check out. Now this is what I need to do. I need to kind of look at the picture that I have and try to figure out what kind of pattern that I have going on. Okay, it looks to me that if I were to put a point at -2, I have myself what appears to be a vertical asymptote at -2. Okay, which means you would do that for me, you would do that for me, you would do that for me. It also appears that as if I were to pick a point like here, if I were to pick a point and notice the behaviors of something, it looks like this guy kind of slopes down and shoots back up like this. Okay, shoots back up like that, which indicates here some type of horizontal or slant rather asymptote. Now only one of these is going to give us a slant asymptote, and a slant asymptote exists when the degree in the numerator is 1 more than the degree in the denominator, and that happens to be d. Okay, you would level out at 0. You would have a horizontal asymptote at 0 because the degree in the denominator is higher than the numerator, and that's not the behavior that we're seeing here. We're showing behavior where it seems to, our graph seems to be increasing along 0, not leveling out. And if you're wondering, well, why not tangent? Why not tangent? Because this doesn't seem to be exploding again. Okay, tangent would do that. Tangent would have like another explosion and hit zeros again after a specific pi value, and that's not happening here, so B is not going to be it. The slope field for a certain differential equation is shown. Which of the following could be a solution to the differential equation with the initial condition of y of 0 equals 1? Well, y of 0 equals 1 means we have the point xy, and that point is 0, 1. At 0, 1, it looks like what's created here is a circle, like that. And it appears to be a circle with a radius of 1 at a center at 0, 0. And the equation of a circle with a radius of 1 at 0, 0 being the center is going to be this guy right here. Okay, you would be a circle but not at 0, 0, and that's a radius of 2. And you would be just linear equations, or not linear equations, some type of weird looking sideways parabola, but that's not what we have. So the answer for this one is going to be D, because that is exactly the picture that we get when we sketch it out.